Now I'm going to talk about the second part of the chapter about the greenhouse gases. And this is a very busy slide, and do not get distracted by that. Okay, it gives you details, help you to understand, but you have to just concentrate on my message. What is a greenhouse? The greenhouse has a glass transparent roof, right? So allow the penetration of the sun rays, but they trap the heat inside of the house because of that glass roof. Now I want you to imagine the earth is a greenhouse. Where is a glass roof then? The glass roof is our atmosphere. And the heroes, the key players here, are carbon dioxide, methane, nitrous oxide, CFC, HFC. So those are the major greenhouse gases. I just want you to pay your major attention to carbon dioxide because it accounted for more than 60% of the warming of the planet. Okay, so this glass roof may not be just the upper layer of the atmosphere. I just use that as one example. But I want you to understand the greenhouse gases in this atmosphere, they trap the heat, trying to escape from the surface of the Earth to the space. If we look at the lifetime of those greenhouse gases, carbon dioxide is extremely stable. It can linger in the atmosphere for 50 to 200 years. That's a long time. Which means once we emit it, they never go off in our lifetime, probably. So that's a long time. And the methane is 12 years, nitrous oxide is 120 years, but we have very low concentration of this gas. CFC and HFCs, those are the chemicals we used to use for the refrigerator to cool the air down. And first we made CFC and turned out to be really bad for the ozone layer, right? They react with the ozone layer was gone, and the skin cancer went up. So we banned CFC. We tried to find an alternative, which is HFC, which later proved to be even worse than CFC. So we just banned those two chemicals altogether. And you can see the potential of those gases trapping the heat. And the CFC and the HFC is much, much worse than the CO2 and the methane. And methane has a shorter life, but it has more potential to trap the heat. So it is bad too. But it only accounts for about less than 20% of global warming. So I want you to concentrate on CO2, the carbon dioxide. Clearly, it is a greenhouse gas. It can absorb the infrared radiation heat from the sunshine. And if we don't have carbon dioxide, our Earth will be extremely cold, okay? It will be 0F and a minus, sorry, I didn't blue here. It's a minus 18 degrees Celsius. It would be like freezer. And because of the presence of carbon dioxide, we have a warm planet, a habitable planet with a current temperature of about 15 degrees. That's the average temperature over the surface of the Earth. But if we have too much carbon dioxide, okay, we cannot live without carbon dioxide. But if there's too many, we have a huge problem here. And this is Annenberg data from the scientists. They present their calculation over the millions of years to very recently. Okay, and they clearly show there is a spike of carbon dioxide concentration in the recent few hundred years, and they keep growing up. And please realize that in the past millions of years, we do not have this huge spike. This is the strongest evidence that the planet is warming. And look at how many greenhouse gases we emit into the atmosphere. It's just going up and crazy. And this is a different gases. No, it's not a different gases. This is a CO2 from burning of coal, oil, and the gas, and making cement. This is a cement. Okay, this is the natural gas. We burn the natural gas for heat and the cooking, right? And we the majority is the oil and the coal. So burning fossil fuel is clearly the major causes of this huge spike of concentration of carbon dioxide in our atmosphere. And it's a huge player in the global warming, and it resulted also from deforestation. This is a really bad decision to remove the forests. Hopefully by now you know why it is so bad, right? It's the carbon sinks. When we remove the forests, we release millions of tons carbons into the atmosphere, and we have nothing to hold the soil. The soil erosion get bad, and we cannot have sustainable agriculture. So deforestation is unfortunately a very bad thing we human did to the planet. And now look at the wildfires. The last year's Australian wildfire released 900 million tons of carbon emission. And this year was estimated to be 19 million tons of carbon emission. It just top off the sum of all the power plants. This is how bad the wildfire is. And it released more carbon in the atmosphere, that adding to the worsening of the global warming. So this is evidence the carbon dioxide concentration keep going up. And today it's about 400 ppm, parts per million. It used to be 280 before industrial evolution. And the methane, it comes from the decomposition, right? And from the natural microorganisms, they absorb the oxygen, release carbon dioxide. We just discover why biosphere 2 failed, right? Because we don't know how sophisticated this process is. We didn't realize how much oxygen this process assumed, and it certainly released a lot of methane into the atmosphere, and burning of the fossil fuel is another reason. And agriculture practice add tons of nitrogen-containing fertilizers, right? When they get degraded in the water or in the soil, tons of methane goes into the atmosphere. And nitrous oxide, the concentration is very low. Here we're talking about ppb, parts per billion. Okay, that's 1,000-fold less the concentration we use as ppm. But because of the agricultural practice, because of using fertilizers and the fossil fuel, this concentration is keep going up also. I will just wrap up the second part of the lecture here.